Hello, this is the Viking Initiative. We're gonna talk about the AP Calculus VC part, and then today is gonna be about Squeeze Theorem, which is like a difficult concept in Unit 1, appears a lot in the multiple choice parts, often like 2 to 3 problems every year on the AP test. And then just asking about what is the Squeeze Theorem. So we must have 3 functions, h of x, g of x, and f of x, where h of x must be smaller than g of x, smaller than f of x. When x is like, as seen in the graph, like h of x, the lowest, g of x in the middle, f of x above, just make sure it must be true in all the domains. So any x value we saw, this must be met. And then when x is approaching to a, when f of x equals f of x equals the value of L, then x approaching to h of x over to L. This is like easy to understand because h of x and f of x, if they are equal, the only value that is going to meet the condition of bigger than or equal to h of x, smaller than or equal to f of x, is the value which h of x and f of x will attain, which is L in this case. And then why will we use the squeeze theorem? Sometimes those direct substitution won't just work, because if I give you something like sine 1 over x in a function, maybe ex squared sine 1 over x, something like this, people will be pretty confused, and then direct substitution just not gonna work. And then sometimes if it just makes our life easier, it can make one very complex function, maybe with a lot of oscillation, to two simpler functions. We can conclude the limit easier. Okay, so one of the example is this very simple written by ChatGPT, where it tells you g of x is x squared and then h of x is negative x squared. And then we have f of x is x squared sine 1 over x for x not equal to 0. We gotta show that negative x squared is less than f of x, less than or equal to x squared. In this case, what we see is this function, sine 1 over x. This have a range of -1 to 1. So the smallest number, -1. If we plug that in, it's x squared, which is like minimum value. The biggest value, 1, which you plug in, is x squared, which is the max value. So f of x must fall in between. So, but what will happen if the limit of x is approaching to 0? The left side, negative x squared, is 0. And the right side, x squared, is also approaching to 0. So according to Squeeze theorem, in this case, if x is approaching 0, f of x must also be 0. And then another example, same thing here, just x squared cosine 1 over x. I just replace them with cosine. And then the same thing, cosine, they're like similar functions. They only have a phase difference of pi over 2, so same range. It varies between -1 and 1. So thus, like negative x squared would be smaller than the function, which is smaller than x squared. And then thus, similar to the previous slide, according to the squeeze theorem, limit is 0. Okay, now time for some AP style questions. This is just simpler, giving you a trig bond, asking you like what is the value of x, in this case approaching infinity, was 2 minus cosine x over x plus 3. So we'll have like -1 is less than cosine x or equal to like +1. We plug in the bond here because cosine x is the one with like a very, very, very clear bond, so which is -1 or 1. Always fine for those type of things. And then when we plug in -1 and +1, we'll find the two sides of bonds, which is 1 over x plus 3 and then 3 over x plus 3. And then the functions are gonna go in the middle. And then in this case, those functions are very simple. When x is approaching infinity, both of them is 0 because it's a number over infinity. Like, so for two sides of 0, the only option left for the function is also 0. Thus, it is going to approach to 0 when x going infinity. And also, we can also use for it to prove continuity. When f of x, in this case, it give you like a function f of x. When x is not 0, the function is x squared sine 1 over x. And then when x is 0, it is 0. If we want to prove continuity, then you guys can pause the video and then try it yourself. But just keep in mind the 3 conditions of the continuity, and then just think about maybe proving it 1 by 1. Then you'll get full marks. 3, 2, One? Yeah, good. Okay, so first condition is f of 0 must be defined. And then the second condition is limit x approaching to 0, f of x must exist. And then the third is limit x going to 0, f of x is f of 0. Number one is simple. It tells you literally here, x is 0, it is 0. And then also when limit x approaching to 0, f of x exists. We did it with the ChatGPT simple problem. It is 0, limit approaching to 0 because of the sign. I'm not going to expand. Because of the trig function, it oscillates from -1 to 1, blah, 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 same thing. And then 3, if you can see limit x approaching to 0, f of x is 0, which is the value of f of 0. Thus, all three conditions are met. This is continuous. And then the last common type of question is for those, it gives you a lot of graphs and then asking you maybe like interpret the graph and then stuff, or asking which graph is correct. And then here is like a question I pulled from AP Classroom with this saying, let f be a function of x. The value of limit x approaching to a f of x can be found using Squeeze Theorem with the function g of h, which the following could be graphed f, g, and h. To do this problem, okay, first I tell you the answer is D, and then to do this problem, we gotta think very carefully about, like, for us to use Squeeze theorem, we must have to meet the condition that f of x is bigger than g of x and is smaller than or equal to h of x in all the x domains. And then also at point A, limit of h of x approaching to a, and then x approaching to a, the value of g of x must be equal. So that's how it only leave f of x one function for us to complete one specific limit. Keeping those in mind, you guys can think about why is it D first, and then I'll go over it in a bit. Okay, I assume you guys paused, and then A, why is it incorrect? It's because, like, looking at this part, f of x is bigger than h of x, and then this part f of x is lower than g of x. So this contradicts that in all the domain, f of x must be in between h of x and g of x. And then also for b, like, why is it incorrect? Exact same thing. Like, when x is bigger than a, f of x become larger than h of x, which also makes it incorrect, and then, like, fail to use Squeeze theorem. And then C, even though f of x is always smaller than or equal to h of x, bigger than or equal to g of x, but when limit x approaching to a, h of x does not equal to g of x. So f of x, the value can oscillate all places in between here. You cannot draw a specific conclusion about the limit x approaching to a of f of x. But why is D correct? It just meets all the conditions. It's always smaller than or equal to h of x, always bigger than or equal to g of x, and then at point A, when x approaching to a, h of x equals to g of x, which leaves f of x only one option in this case, which is whatever it is. And then, yeah, that's why it could be applied. That's pretty much all the possible contents or the question types about the Squeeze theorem. It looks straightforward. Sometimes just don't get confused on those multiple choice questions, and then that's going to be it. If you have any more questions, visit our Viking Initiative websites, and then found the AP Calculus BC group inside, and then add our WhatsApp. We will have tutors here to enter all the questions. Thank you so much.